find that blue segment, the first thing you're going to want to do is actually find the area of everything that's blue here. Okay? So in doing that, and that's the area of your sector, or area of sector, we know that formula is x over 360 times pi r squared. And when I say x, I'm just talking about the arc that I'm using here that defines the sector. So what would that be in that case? 120. So 120 over 360 times pi. Now what is r for this thing? 12. And I'll square that. Okay? So that's going to give me 12 divided by 36 is a third, right? And this is going to give me 144 pi. A third of 144 is 48. So 48 pi is the area of my sector. Is that all right? It's the area of everything that's blue. Now, if we remove from it the area of the triangle, would that be leaving us what we're trying to find? So let's go through and see if we can figure out the area of our triangle. All right, so area of a triangle, 1/2 BH, right? So we need those components for this figure. The easiest thing, guys, there are 3 H's here, but I think you're going to find out, so I'll draw one of these altitudes here. That is an H for that triangle, but that's probably not one that you're going to be able to find easily. Does that make sense? In all these problems, the easiest altitude for you to find is that one there. Anybody know why? What kind of triangle is that? It's isosceles. So that's 12, right? Meaning that this thing here, if it's perpendicular to this chord, then it's going to bisect that chord. And it's also bisecting this angle up here, right? Now, the reason I need to know that it bisects that angle up there is what is that entire red angle there? 120. But if I bisect it, how big is just one of those angles? 60. What did we just create? 30, 60, 90 triangle. And 12 is which side? It's the hypotenuse, so it's 2 n and a 30, 60, 90, right? So n would be 6. And n is the side that's across from what? From 30 or from 60? N is across from 30. Okay? So that makes that distance 6. What is that distance right there? N radical 3, so 6 radical 3. All right, so if that's the case, how big is that segment right there? 12 radical 3. And that 12, that's your B, right? So H is 6, and B is 12 radical 3. Multiplying that stuff out, you should get 36 radical 3. And that's the area of your triangle. Now, what do I need to do with that number there and that number there? Subtract them. So, the area of this blue stuff is 48 pi minus 36 radical 3. That's the exact area. I know the question says put it in like the nearest tenth or whatever. That will do that. Okay, once I take that, type in my calculator, I'll get the nearest tenth. I'll get the nearest 100, nearest 1,000, 10,000, 100,000, whatever I want, I will have. Okay? I want to focus on doing this as using exact values. So, going through there, all right? Area of a sector formula, okay? Area of a triangle formula. We need to know things about arcs and central angles. We need to know stuff about special right triangles. We need to know stuff about altitudes of isosceles triangles, okay, and angle bisectors, okay? There's a lot of stuff wrapped inside that question, right? Okay? If we forget one of those things, we end up with a problem, okay? And that's mathematics in general in the real world, is that there's usually not just one concept or one thing kind of at play. There's a variety of a cluster of different aspects, different concepts intertwined that we use to explain things in the real world. Okay? And that's something that hopefully this class is starting to get you guys to focus on and realize that it's not like a lot of other math classes you've taken where you focus directly on one thing and one thing only for a question. Okay? There's like 5 chapters of information involved in that problem. Okay? That's geometry. Okay? That's measurement. That's how things happen. Are there any others in there that you guys want to talk about? I'm assuming there's a couple other that are similar to that. What'd you say?
The one where it's like a square, and it has like weird. Yeah.
17.
And that one, yeah, we go.
All right. Let me just read it to see what I need to pull out here. Cut and paste. Refer to the diagram of the regular hexagonal nut. It's the area of the hexagon with radius 10 meters, 10 meters, millimeter with the area of the circle. Okay. So what we've got going on here, I'll cut this picture out. All right, so that's the hexagonal nut that we're interested in, but I'm going to kind of give myself a bird's eye view of this thing. So I'm going to turn it into looking straight down on it. All right, so we should have something like that, right? Okay. Now it's telling me that basically there's 3 questions here in this problem, and they're stacking them on purpose. The overall goal is to find out what is the area of the blue region, what's left over blue in this picture right here. Does that make sense? So as the question evolves, they ask you first find the area of that thing, then find the area of the circle. And then part C says find the area that's blue. Well, what would I do with the area of the, I would subtract them, right? Okay. So let's go through and find the area of, I think finding the area of the circle is probably easiest. So let's maybe do that first. All right, so if I find the area of the circle, that is equal to pi r squared, right?
Yeah.
Or if I look at that radius, what does this picture tell me that radius is? 5. So the area of that thing is 25 pi, correct? And that's going to be millimeters squared. Now I got to find the area of this thing, which if you remember finding the area of a hexagon, Tyler, what's the formula for finding the area of a hexagon? Fantastic. Okay, so 1/2 AP, where A is the apothem, right? Cursor died, so hold on a second. There we go. So A is that there. P is the perimeter, correct? Okay. Now, as I go through this, I don't know a whole lot about this shape. That there is 2 millimeters, and I think that's just there. We don't really use that thing. If I look at this distance here, this 10 millimeters, that's the radius of the hexagon, right? Is that 10 millimeters? Is it that distance there? Is that the same as that right there? Let me use a different color over there. Actually, let me do this. Well, maybe I can't. There we go. All right, so that's 10. Okay. Do you have the ability then to figure out what that angle right there is? We've done that, right? That's 360 over 2n. 360 divided by 12 in this case would give me 30 degrees. That's nice because now this thing here is the 2n, correct? Does that make this side right here, so n would be 5, does that make that 5? Does that make my apothem 5 root 3? Okay, so now finding the area here would be 1/2 my apothem, which is 5 radical 3, times my perimeter. What's my perimeter of this thing going to be? It's 60 because that's 5 as well, right? So its side length is 10. 10 times 6 would be 60. It doesn't matter, you're fine. So then when we multiply this stuff together, you get 1/2 times 60 is 30. 30 times 5 is 150. And we got a radical 3, right? There's the area of that hexagon. The area of your circle was 25 pi. What do I need to do with those two areas to find this blue region over here? Subtract them. Which one's bigger? 150 root 3, right? Does order of subtraction matter? Yeah, if I reverse this, I get a negative answer, right? If you're a person that doesn't understand or realize which one's bigger and which one's smaller, well, absolute value always forces my area to be positive. Yeah, you do that. I don't know if it's the correct approach. I would much rather you understand that you need to find out which one's bigger and use that first. But absolute value will garner that same solution for you. Okay. Now I know it says to the nearest tenth or whatever, or hundredths. You now have exact, so you can go through and do those things. Okay. And I'm pretty sure that's all that question was asking for. Area of the hexagon, area of the circle, area of the hexagonal face. Okay. Now eventually, next chapter, this 2 millimeters that I crossed out there, that will come into play. And our goal will be, okay, now find the volume of metal that is necessary for creating that nut. And the way you do that is first find that area we just found. Does that make sense? Okay. So this question will come back to us in some fashion in the next couple days. All right, so you said that there was one that had a square in it too?
Square and then like a weird diamond in it. That one.
It's good to talk about because you're going to have a question similar to this in your homework tonight. Leave answer. So they want to find the area of the shaded region. Leave answer in terms of pi and simplest radical form. So no rounding, nothing like that. Keep everything exact. All right, so how do you know it's a square? All right, so these little marks, these little orange marks, are going to tell us that eventually that this thing does end up being a square, right? Do you have the ability to find the area of that square? Okay, what would the area of that square be? Okay, side squared. And what is a side right here for me? 20, right? This here, this distance right there is 10. So side is 20. So 20 squared is 400. So 400 square inches. Okay. What is this thing? What is this shape here? It's a sector. It's a quarter of a circle here. Because, and the fact that it's a quarter of a circle is known because that's a right angle, right? Okay, so this arc would be 90 degrees. So it's a quarter of a circle. Well, what's a quarter plus a quarter plus a quarter plus a quarter? It's the whole thing, right? So is that a whole circle? Okay, so here's my question. What would be the radius of this circle? Radius of that circle would be 10. Do you know how to find the area of a circle? Pi r squared, right? You agree that that's going to be r is 100, or 10, so square it, you get 100. Multiply by pi. Is that the area of that circle? Okay. So what do I do with these two numbers then to come up with this shaded irregular shape? Subtract them. 400 minus 100 pi. That's going to be inches squared. Is it any different than putting the circle there and asking you to find these areas? No. It's the same, because think about this. If I were to put in that segment right there and that segment right there, is this region here, that one down there. That makes sense? So I could alter the question a little bit by putting the circles, or kind of divvying up the circle in a little bit of a different fashion and kind of jamming it inside that square differently. Does that make sense? Yeah. Okay. You see a question like this in your homework tonight. Deals with triangles instead, though. Okay. Others? Derek? 21. Aha, yes. You see one of these in tonight's homework. Well, good. Now you're getting the opportunity. That's the thing about learning. You do something wrong, you see why you did it wrong, you go back and see, can I do it right now? Hey. All right. If we look at this, all right, we're looking for the shaded region. In doing that, would you guys agree that if I found the whole circle and then remove this white stuff, it would give me the orange stuff? Okay. So I need to set up just kind of a basic general process. I'm going to take the area of the entire circle, and I'm going to subtract away from it the area of the segment. Okay? Now, that's kind of involved because if you remember, the area of a segment is this thing right here, right? It's this procedure here. So I'm going to rewrite this here as, just so I can realize the components that I need to find. Area of a circle minus, now the area of a segment is found by taking the area of the sector minus the area of the triangle, right? If I can do that stuff, come up with that kind of procedural formula, it tells me how to go about the problem, right? And that's what you guys got to do a lot of times. It's the scientific method, isn't it? Okay? What's my problem? Okay, try to develop a plan that attacks that problem, run through that plan, get an answer, and see if that answer matches the question at hand, right? Or answers the question at hand. That's what we're doing here. We're setting up a plan, okay? Now, once we have that plan set up, go through and conduct that plan. So let's find the area of the circle. What would the area of this circle be? Be 9 pi, right? Pi r squared with r being 3 gets 9 pi. All right. Let's find then the area of the sector. Area of the sector, remember sector is x over 360 times pi r squared, right? Well, what's nice about that, do I already have pi r squared for this circle? I've got 9 pi already, right? Okay. I just got to figure out what portion of this circle is that shaded sector right there. 120 over 360, and that is 1/3. So 1/3 of 9 pi is 3 pi. Okay. Now I got to find the area of the triangle. Very similar to the one we've already done. Draw that segment down. What does this angle right here become? 60. This is 30, right? This becomes 2n. So what would n be? 3 over 2. Okay? So that's 3 over 2. So this distance here, okay, this altitude for the triangle, that's h, and it's 3 over 2. What would that distance right there be? 3 over 2 radical 3. What then is the entire base of that triangle if half of it is 3 over 2 radical 3? It's 3 over 2 radical 3. What do I get if I double that? Yeah, I just get 3 radical 3, right? So find area, it's 1/2 BH. So we got 1/2 B, you just told me was 3 radical 3. H was this 3/2. Multiply that stuff out. I get numerator is 1 times 3 times 3 is 9 times radical 3. And the denominator is 2 times 1 times 2, so 4. There's the area of my triangle. Okay? So up here, if I know the individual components I had to find, and I found them, I just plug those things back up into this, right? So I'm going to go 9 pi, that's the area of the circle, minus the area of the sector, which was 3 pi, minus the area of the triangle, which is 9 radical 3 over 4. Okay? Now, if I want to leave this thing as an exact answer, there's some like terms here that we got to deal with. Okay? And I also have to pay attention to minus a quantity, right? If I look at this, does that mean, or does that imply 9 pi minus 3 pi minus a negative 9 radical 3 over 4? What's minus a negative? Plus. So now what's 9 pi minus 3 pi? 6 pi. Now I have my 9 radical 3 over 4. And that's good enough. If you want to put a common denominator of 4 in there, that's fine. So you could have 24 pi plus 9 radical 3 over 4. But that's sufficient there. Okay. Okay. Yes. Okay, so you could so this approach is fine, okay? But you could also do this idea where if I find, because this thing here is also a sector, right? Okay, so that's a sector, and that sector would be 240 over 360 times 9 pi. So that'd be 2/3 of 9 pi, which is 6 pi, right? Okay. Then you can find the area of that triangle. And what would I do with the 6 pi in the area of that triangle? Add them together. What was the area of that triangle? What we said it was 1/2. B was it 3 radical 3? And 3 over 2. So does that still give me 9 radical 3 over 4 plus 6 pi? Same way we found it through subtraction, right? Either method is perfectly fine. Okay. When I look at that, I see the subtractive thing. Okay. If you see additive ideas, go ahead and use them. It's fine. It works. Okay. Guess what?
What?
See one of them in your homework.
Yay.
Any others?
That one.
Seriously?
No, seriously, do you just take 360 minus 90?
Okay.
Like that?
So 270 over 360 times pi r squared. All right?
I got that one wrong.
Do you know which one it was or where it was at?
That one.
In a circle, a 90-degree sector has an area of 49 pi squared. Okay? So when they say sector, you know what that means. X degrees over 360 times pi r squared, right? That's the area of a sector. You know that the x right now is 90 degrees, don't you? Times pi r squared. They ask what is the radius, so in your formula, in your equation here, that's going to be the unknown. You don't know it, you're looking for that. So this, remember, this is a variable, right? It's an unknown area at the onset. This is a variable, that's a variable. If I want to solve for one of those variables, I need to know the other two, right? In this problem, you know that variable of capital A. You know it's 49 pi, don't you? Okay. Does that leave me an equation that has one variable that I can solve for? What's 90 divided by 360? 1/4. Okay. How can I get rid of that 1/4? Multiply everything by 4, right? Both sides by 4. Would give me 196 pi equals pi r squared, right? Pi is a coefficient. So how can I get that coefficient to go away? Divide by it. Come over here, divide by it. So now it leaves me 196 is equal to r squared. So how do I solve for r? Square root. Square root of 196 is 14. So the radius of the circle is 14. And you should be able to be good from there. Then you didn't do that. You got any work? Any work? Switch it around. Any others? All right. So area of circle, area of sectors, arc length of arc length of portions of circles, that kind of stuff. Are we comfortable with that right now? Okay. I'm going to give you a worksheet, and it's going to reiterate what we just did.